Hey, what's going on, folks? It's Mike here, and welcome to the Programming Language First Impression series, in which we take about an hour or so to look at a programming language for the first time. And I just give you my impression, how easy it is to pick up the materials, how easy it is to install the compiler or interpreter, and so forth. So with that said, we'll have a little bit of fun, and we generally don't compare which language is better, but we might look at similarities and differences between languages and just overall uncover some different ways of programming. Now, today's language has been a language that the people of this community have been asking for, and your asks have been, well, received here. So with that said, let's go ahead and take a look at today's programming language, which is Ada, the Ada programming language. And this is one that I'm really excited to actually look at, if you can't tell, because I've been very curious about Ada for a long time, since looking through library shelves and finding all these Ada books. I remember at my university library. And our curriculum at my undergraduate university used to actually teach part of their course sequence in Ada. So I wonder what sort of happened as far as that went, but it's actually still a active language as far as I understand. And there's some really cool projects. So I want to go ahead and take a look at this modern, very modern programming language. And we're going to go ahead and start with the Wikipedia page, and then I've got the Ada core homepage here. But let's just go ahead and start with some of the wiki history here that's been kept. So with that said, what is Ada all about? Well, it's a structured, statically typed, imperative, and object-oriented programming language, and it's inspired by Pascal as well as other languages. Now, of course, we've looked at Pascal in this series, which is one of my near and dear programming languages as well, that I remember learning the free Pascal, specifically with the Lazarus project, or Lazarus, however you pronounce it. But anyways, so I like that family of languages. So already, Ada's in good company here. And it's inspired or a language that's built in with design by contract, okay, with extremely strong typing. Now, this is something that's sort of grown into favor over time, having very type-safe systems. I mean, we see this in programming languages, but it's interesting to see if we look at Ada, right? It's got all the way Ada 83. I wonder when this first appeared here. 1980, it says, 43 years ago. So, I don't know if design by contract was all the way in 1980. I suspect it actually might have been, because I know a little bit of the history just from programming language courses about Ada and how it got developed. But that might be a relatively large innovation a long time ago. And it's interesting to see how these trends have sort of become more and more popular, right? Stronger typing versus dynamically typed languages. Now, programming languages tend to sort of move in waves and cycles as far as what's sort of popular at any given time here. But that's kind of interesting. And design by contract is something we see in different languages. Languages like D, for instance, have pre and post contracts that you can put in classes and functions. C++ is going to get some sort of form of contracts. I'm really curious to see what Ada has and if that's influenced some of these other modern languages. Explicit concurrency, tasks, synchronous message passing, protected objects, and non-determinism. Ada improves code safety and maintainability by using the compiler to find errors in favor of runtime errors. Well, I love that, because that's another trend that, again, we are seeing in programming languages, right? Case in point, Rust, one of the most popular programming languages these days. You try to do stuff at compile time, especially for concurrency related bugs and so on. That's a big thing with Rust here. Now, it's interesting to see, Ada, again, it's sort of like, when you talk about C++, we talk about modern C++. C++, language that's been around for 50 years. Ada here, language that's been here 43 years at the time of this recording. So it's interesting to see that, as of May 2023, so very recent, 7 months or so since this recording here, has called the standard here for Ada 2022. So there's a relatively new release of this language here that folks could be using. All right, and a little bit about the history. So it's designed by, let's see, French computer scientist Jean Iquebia of Honeywell under contract by the United States Department of Defense. So that's what I know a little bit about. I knew some faculty who actually worked on the language. And what I recall is Ada at the time, again, this is my memory, we'll look at it, was going to be this really, really big language. Now, as we found out, pretty much every programming language, whether we like it or not, although other cases like Go are designed to be very small, but most programming languages tend to grow over time, right? We get more features, different things become popular, but you want to maintain your old code. So that's sort of inevitable. But I remember Ada specifically being a really, really big language. So, I mean, it sounds like if it has some of these features like design by contract, for instance, I mean, those would have been, we'll see how far they take it, or all these different models of concurrency. That might have made the language very big and intimidating at the time. So we'll see where it actually stands today. Now, the other cool fact, of course, as you might have guessed, Ada, named after Ada Lovelace, who has often been credited as the first programmer. That's just a little bit of history you should know, and maybe we'll make Ada Lovelace and some of these names, Grace Hopper, and so on. Francis Allen, a few other folks that we want to make sort of some, household names. I mean, no other, and so on. Some of the women in our computer science world here. So anyways, let's see here. Ada, originally designed for embedded and real-time systems. Okay, sort of makes sense here. But interesting to see, again, if you're designing for real-time systems, how important it is to be able to catch as many errors as you can at compile time, right? We do this as programmers when we put things like asserts in our programs, for instance, because we as the developers want to make sure, bugs don't get out. Even though we're not necessarily testing the system, when we have some of these compile time constructs, or constructs rather, like static asserts and stuff to capture errors, that's still really important for the real-time system reliability here. All right, so we've kind of looked at some of these examples here. I think I'm going to go ahead and just get us started here. Let's see, there's large compile time checks. Well, now this is kind of interesting here. And that we've only seen really in Rust, as far as I'm aware, in the programming languages that we've looked at. That could or could not be true, because maybe some languages like OCaml and stuff that have a little bit more formal proofs might be able to do this as well. But it's interesting to see that Ada can actually catch at, let's see, these deadlocks here. Now, is that at compile time? Let's see here. As concurrency is part of a language compiler, yeah, the compiler can in some case detect potential deadlocks. And I wonder if that's at runtime or at compile time, if we could sort of prove the case, because we do have things like sanitizers and so on. Now, interestingly, I'm going to install Ada here in a second. I just want to do a search here, because if my memory is correct here, I believe, let's see, as far as the GCC front ends, is there one for Ada? Let's see here. Yeah, currently the main GCC distribution contains front ends for C, C++, Objective-C, Fortran, Ada, Go, and D. And there are several, more that are being probably integrated. I'm sure there'll be like a Rust one at some time. But yeah, interesting. Ada is here. Okay, so it's in the GCC ecosystem. We might already have this installed. I can't remember when I compiled GCC if I put Ada in or not. Okay, so it's been used in a lot of different places, space agencies, and so on. Okay, and then we've got the whole history here. Okay, so pretty interesting development to see Ada. I think this is one of the first like big languages with, a committee and an ISO standard and these types of things. So there might be some real interesting programming language history here. And it looks like it's getting a new like standard every few years, which is, if you're in this community, probably great to see it getting updated here. Okay. And then, yeah, we got a little help world, but we're going to write this ourselves. And clearly we can see this like very clearly influenced by Pascal or Modula 2, or, that family of languages. I think this is actually kind of neat. Procedure hello is, I mean, that's almost like very English, like we were looking at Perl, if you're watching the previous episode here, right? You could just sort of read this like a sentence. And I also like this end, and it's telling you exactly what procedure. So again, maybe a time before we had text editors that could sort of show us the context of which function we're in or which block. But that's kind of neat to see this here. Okay, so anyways, let's get into Ada here. Let's see if this is the right place here. Ada language, Ada core, I'm assuming. And then there's adalang.io. Okay, let's see. Are we in the right one here? Which one here? Well, let's look at both of these because I found both these resources. And then Ada core has like some introductions here. What is the official site here? adalang-io. I'm going to assume it's this Ada core one. Let's see, yeah, because that's probably the first one that we found here. Let's see if it's got like a foundation, but we might hold on to this one too, because it's got a way to just download it nicely here. Get started with Alier, the Ada package manager. Okay, cool. So learn something there, but Ada core, let's go ahead and start here and see what we got here. Products. Oh, this looks like a company doing Ada stuff here. Okay, so this might be the first time we found like a company here that's actually backing the tools here. I actually do want to look at this. I think, let's see, if I do in Google Ada language official website. It looks like it's the Ada Lang-IO. So we will go to that one in a second. But I actually want to look at the Ada core. So, free, advertisement for this company, I guess. But kind of interesting to see here. Looks like they have an Ada 12 compiler here. They've got some folks talking about the Ada story here. Let's zoom in on this a little bit here and see. I mean, they're showing off all the features here. Yeah, this is kind of cool. Okay, we got the different tools here. So it's going to be packages. I mean, there's tons and tons of features. Okay, maybe we'll go to Ada Lang-IO in a second. We got the history, similar to what we have read on the Wikipedia here. Okay, yeah, and then of course the story about Ada and the programmer Ada, who worked with Charles Babbage on his machine, and the daughter of course, the poet Lord Byron. Okay, Ada core. So there's a bunch of stuff here. Okay, so there's a cool like environment here. Okay, but I'm just kind of curious what's going on in the academic world here. Okay, we can get some support here. Okay, and there's Ada Spark. This is actually what I want to look at because I've heard of this. But I want to actually take a look here. Now, it looks like Ada is being used in many, many places here. Probably different domains here. Let's see, what is Spark here? Something is a software development technology specifically designed for engineering high reliability. Interesting. So, I mean, we looked at in the wiki, some of the agencies that might use this, like space companies might be interested in this, car companies, robotics, and so on. Interesting. Spark code can be combined with full Ada code or with C. Oh, interesting. Okay, so there's a lot of static verification. Okay, so again, looks like this Ada core stuff is building tools and, releasing all sorts of stuff to build secure software. Great. Let's look at the Ada Lang.io website here and go ahead and get started here. Okay, we got a package manager, Spark here, and embedded. Okay, so we got to kind of figure out what some of these things are. But showing off different examples, I suppose, here. Yeah, let's get started. Let's see where this takes us. Why Ada? Well, let's see. Readable, correct, and performant. Okay, so of course this is a compiled language, as we've learned, right? There is a compiler doing checks at runtime and compile time for us, apparently. Correct. And you could build native applications and, of course, bind to C and C++, which is sort of a requirement. Interesting. And then they've got RAII, resource allocation is initialization, one of the popular things, and a good thing, I actually like as far as features go from C++. Okay, so we got the tool chain here. Oh, interesting here. Okay, so I don't know how to pronounce this, a leer or a liar. Basically, they've got a crate. Now, we saw crates with Rust, but a similar idea with package management here. I mean, looks like they made it really simple here. So that might be a really nice ecosystem here in Ada that we're not so aware of here. Let's see. From memory safety to functional correctness. Okay, restrict Ada packages to the Spark subset. Okay, we'll have to read a little bit. Maybe the wiki can give us, if I search Spark here. Okay, Spark, a programming language consisting of a highly restricted subset of Ada, annotated with meta information describing desired component behavior and individual runtime requirements. Okay, great. So that sort of answers that question. So there is like maybe a safe subset, and I could see this in various, like if you're in the auto industry or aviation, for instance, that you want a restricted subset that's like safe, could be formally verified, compiler can have extra checks for different things. That sort of makes sense. Okay, and they're doing maybe some data flow analysis. That's kind of interesting here. I wonder what kind of data flow analysis do they have? Do they have things like taint analysis where you can follow corrupted memory, or, there's all sorts of interesting analyses that you could do here, or even just for like simple memory leak stuff. Let's see. Prove the absence of runtime errors. No buffer and arithmetic overflow, division by zero, or values out of range, among others that can occur. Okay, so this is pretty cool. I mean, buffer overflow is still like the most, it's the $1 billion mistake as far as things go. So interesting. Okay, so let's figure out how to like just get started here. Why Ada? Okay, let's see. Okay, so we're covering every Ada feature that would dilute the conceptual overview of Ada. So related Ada specific terminology is quoted in parentheses for those wanting to do their own targeted research. Okay. No, we just want to follow along this tutorial here. Ada supports, okay, tons of different things here. Some types, okay, we got variants, discriminates, static polymorphism, monomorphism, generics, dynamic polymorphism with dynamic dispatch, and virtual functions. So it's got a lot of C++ type of stuff here, with some other some types which are very popular. Forced namespacing with packages, okay, function overloading. Semantic types, saying that two things are the same backing type and not the same type of thing. Think of miles versus kilometers. Yeah. This is a nice one. I'll be curious to see how this is done. I've seen this done in some libraries, for instance, where you want to create something. I mean, conceptually, it's a float, right? Like maybe you're representing a mile or kilometer before, but you want to still assign a type here just so you can't multiply miles by kilometers. Without either doing the proper type conversion or whatever. So that's kind of nice. Deterministic construction, RAII, design by contract, yeah, precondition and postcondition, and aspects. Okay, interesting. I'll have to actually look at that. I've used this before. Again, in my undergrad, we had to write precondition, postcondition, and aspects, but I wonder what it means in the Ada context. Let's see. Task definition with defined synchronization and queuing strategies. Interesting. Okay, rendezvous, entry, select, accept, and so on. Ravenscar. Okay. Okay, so Ada is missing a preprocessor. Now, some might say that's actually a good thing. A lot of folks don't like a preprocessor or macros, for that matter, for code understandability. Now, reflection could be a big one that some folks miss. Although there's ways to build your own reflection systems, so maybe there's some ways to have a little bit of introspection. Periodic templates, async, await. Okay, it has tasks and entries instead. Okay, so anyways, let's look through a little bit of this. Let's get to the hello world. Okay, so traditionally the first command in the language is hello world. That is correct. It's a simple program. We'll have a greeting. Okay, requirements. Let's go ahead and install this here. This program provides simple commands to build and run your code and will install the programs behind the process. The detailed controls are still in the background if you need them. Yeah, let's just use this package manager. I'm fine with this, right? If it's got a way to make things easy, let's download it. Give that a second or two. Okay, that was literally like a second or two. Okay, let's see here. Is it as simple as just ALR? Okay. ALR is the command here. Oh, nice. All right, very clean. This is the version that we're using, 1.22, if that matters here. Okay, and we'll just, we got our build commands, testing, executing, launching. Okay, simple enough here. Build. Let's see what happens here in our investigation here. So I guess I'll just run this from the bin. Simple enough. We could add this to our path or something if we want. Let's see here. It looks like supported platforms. Mac, Linux, Windows. That's pretty much all I need personally. But it's also got cross compilers for ARM, RISC-V, and AVR, which I don't know what that is. So interesting. Anyways, let's go ahead here. Let's write our first Ada program. Okay, so Euler, apologies if I'm pronouncing that incorrectly. Maybe something to add to the documentation there. So it runs from the command line terminal, keeps it slim, easily usable. Okay, I believe that. But yeah, let's see. We want to generate a new project. Okay, which runs an executable, which is also called a binary. Yep. Okay, all standard stuff. So let's do this here. Init my binary, my hello world. Okay, let's see. Okay, so this is like our first run. Let's see, we need some user information initialized, create author. Okay, please enter your GitHub login. Oh, okay, interesting. I don't know. Let's just see if I put in Mike, my full name, Mike, my email, mike@mike.com. I wish I had that domain. Okay. So I wonder if I need that or if that's just for the purpose of, creating stuff easily. Let's cd and see what this made for us here. Okay, so we've got some sort of like file here with our basic information. Okay, I mean, that's kind of nice to just get the author or whatever, right? So if I want to I'm imagining if I want to create this as a library or push this upstream so other people can use it, that's very easy. So anyways, okay, so we see the different things here. Yeah, we can just run tree to get the structure. Okay, describes what's in your project. Okay, this is a more detailed file describing how to build your code into a running program or a library. Let's see what that looks like. That's in the source directory. Oh no, the my hello GPR here. Okay, so this is like interestingly, it looks like, I wonder if this is being done within Ada here, or if this is just another domain language. I guess we'll learn here in a second here. I actually kind of like build or package managers that use the language to compile it itself, right? It's a little bit of dog feeding, but it's kind of clear what's going on. Like I could step through in a debugger the actual process for building. Now, maybe that sounds, I don't know. Again, I have to probably do this at scale. You know, maybe there's some build engineer screaming, no, no, it's bad or something, but it seems better for me to get a debugger and be able to see the state of things, versus like a build system where it's like somebody built this tool and you have no idea what the actual state of the program is. So I'm actually kind of a fan of that. I know that's, I don't know, that's what this looks like to me. So that's kind of neat here. So anyways, we'll learn a little bit more about that. Let's see. And then we've got our source and then our share. Interesting. So I guess I'm assuming there's some sort of module system. Again, if it's taking after Pascal, that's probably what it has, right? Versus C++, which has header files and source files, which we're learning are, you know, a module system tends to be a little bit cleaner for us. As much as I like headers for providing an interface, you can have a module that cleans that up here. So anyways, let's run, let's see, can I just run ALR here? No, I gotta do /ALR. Whoops, let's do it from our bin. Yeah, it's just gonna recognize the binary here. And then build. And then it's getting all of my dependencies here. Okay, what do I want to do here? What is this here? If you choose none. Okay, so what is this here? NAT is not currently configured. Let's see what other messages we got here. Welcome to the toolchain selection assistant. In this assistant, you can set up the default toolchain to be used with any crate that does not specify its own top-level dependency. Okay. I'm probably just going to choose none. I don't think I have any dependencies. Let's see. You should see something like this. I don't know here. Choice. I'm just going to hit enter. And then I'm going to hit enter again. And let's just see if it works here for Hello World. But I'm guessing it's downloading the toolchain, maybe the compiler that we need. Again, I think I have it as part of GCC, but I'm not 100% sure. But this seems like a better build system than, I guess, just doing it. Again, I'm leaning more into, I very much like just compiling code from the command line and a makefile, but as I just stated, having a build system or a build system that works within the language is also kind of nice here. So anyways, we'll let this download here for a moment. And oh, it's giving me a nice little like progress visualization. Anyways, let me pause this, and then when it gets 100%, we'll resume. Alrighty, so there it is. You got to see it. We've both finished 100% here. Let's see what the next step is. Let's see here. We installed something successfully. Couldn't find some folder or something. Okay, did it build our thing? That's all I care about, though. Let's see if I build. Cannot continue with invalid session. What does that mean here? Let's see here. Cannot continue with invalid session. Could not detect a session folder at the current or parent locations. Okay, let's see here. Maybe we need to modify our... Let's actually see. Did we get a hello world? Maybe there's no like source code or something. My hello. No, we've got it there. Now we could probably figure out how to build that with GCC or something, versus wrestling with this tool here. Let's see here. Let's go back here. Let's play around with this just a little bit here. ELR, let's see, I ran build. Oops. Go back one more directory. Let's see. Do I have to be in this folder here? Maybe that would make more sense. Build. Oh, that's just the tool here. Okay, let's see here. Okay, now we're getting somewhere here. We got some different commands. Okay, can't find a native tool chain for language Ada here. Okay, so we could probably fix that. Here, let's try to get this in a nicer here format. No compiler for language Ada. Cannot compile. Okay, so I got to figure out how to download Ada then. Let's see here. That must be a way to just download it. Let's see. Maybe I just messed that up with the process here. Let's see. GNAT's the package. I just looked that up here. Let's install version 10 here. Let's see. 86 megs. Okay, so that's pretty quick here. And again, I'll let it run and install, and when it gets 100%, we will hopefully get our hello world working. Alrighty, so it looks like we are getting version 10 or so of this compiler here set up here. And let's see here. Okay, so from the Ada core team, looks like we have a way to at least compile. Let's see if that fixes our build issue here. Let's see. I wonder if we have to like recompile. Maybe I've just messed up this thing here. Let's see here. Let's see. Maybe create a new working release or something. Let's try to just blow this away, this hello world. And let's see. Let's go ahead and rerun that command to build our hello world here. Let's see. What did we do here? We initiated a new project here. And let's just do LR build. See if it works here. Okay, so that's still kind of messed up. Let's just run the compiler maybe. And let's see if I can just build or initiate some sort of new function here. And let's see here. Well, actually, let's see if I've got my hello world here. Now it did build something here. I mean, there's all sorts of stuff going on here. Let's see if I cd into the source. Let's just, again, we just forget the infrastructure here. Let's just get some file running here. What do we do here? Clean, compile. Okay. Compile, maybe? Okay, so what did that do? That gave us an object file. Okay. So I can figure that out here. .ali, I wonder what that is. .adb is the Ada source code. So let's see, we compiled it. Now what do we do here? GNAT, let's see, make. Oh, we got like a make tool here. Find, compile. I mean, do I need a linker here to link this in? I've got the link here. GNAT 10 link. Let's see here. My hello world.o. I don't know what other options to provide it. No ALI file given for link. Oh, interesting. Is it this one here? ALI. Feed that to the linker. Failed. Okay, let's see. Let me find another tutorial here, how to compile this. It looks like, and this is from the like GNU page here, running the simple hello world. It just, oh, I mean, I guess I could just do this with GCC here, or I guess, oh, there's just like the GNAT make here. Let's see here, GNAT or NAT make, and then the file here, my hello world ADB. Okay, and that gave me my hello world, which I could just run, which doesn't do anything, I guess, at this point here. Okay, but that works here. Let's see here. My hello world.adb. Okay, oh, just does null. Okay, perfect. That's fine. We can follow along here. So let's follow along with this tutorial here. And yes, it's just an empty program. And we'll use this make tool here. Let's see, what was it? Make my hello world. Oops, we gotta move into that directory. There we go. Oh, file name missing. .adb. What was it? Let's see. Oh, source slash my hello world.adb. Okay, and then that made the executable. Perfect. Okay, so that'll be our build system here. Okay, that's not bad at all here. That's just me not knowing how to do stuff. So let's compile, we'll make it and then run it right away. Kind of nice again, all the build system seems like it's with the compilers, so apologies I didn't get that Lear or whatever source or package manager working, but cool to see that infrastructure. I'm sure it's neat. But this is also neat, a smart build system. Again, love having all these tools integrated with the compiler. I think that's the right way to go. Just give me all the tools with the compiler. I don't want to have to install a bunch of third-party stuff, or give me an easy way to integrate third-party stuff if possible. Okay, so anyways, here, let's look at the language here. We've got a procedure. This is like in Pascal, begin end blocks. This is begin here. Between these two words is a section of code where additional variables and constants would go. There's no variables or constants used here, so it's just empty, of course. And then null just doesn't do anything. So we have like a no op instruction here. Okay, let's make it do something interesting. There's an empty program with absolutely nothing. Okay, the start of every Ada file is what's called the context clause, where dependencies or other pieces go. In Ada, there are 3 packages provided as part of the language. Though with this A-layer tool, you can bring in other code here. So we've got Ada, basic stuff here, the standard library, and then interfaces to talk to C. Okay, so yeah, let's start with like hello world again, just getting that up and running, because that'll be interesting enough to see with ada.text IO. Okay, easy enough here. And let's go ahead and instead of null, what we will do is do ada.text IO dot put line hello Ada. Okay, and this is a semicolon language. Okay, so easy enough. I go ahead and run it, and we see hello Ada. Okay, not too bad at all here. So I like the ecosystem. Got to get a little bit used to the language here a little bit. The styles here, we've got a lot of underscores to separate things out, but that kind of makes it readable. Again, I wonder if they were going for a more readable, again, you know, being from the Pascal family of language here, that seems to be the syntax here between words. That might also make things more greppable as well, if that's a syntax, so that's not bad here. Okay, we're going to skip the run because we figured out how to do that. Let's see, command line arguments. Let's see where this tutorial is taking us here. Otherwise, we'll find, you know, some other things here. Let's see. Write code comment. Let's see here. Oh, this is going to be building like a little... Okay, yeah, this is just getting through the basic stuff. I think we should go through this. So you're going to write a program that prints the words you give it. No program runs in isolation, though, so these inputs are being given as additional values when they start the program. Okay, so let's go ahead and keep going here. Okay, so here's what we got, our hello world. Comments, 2 dashes. I actually kind of like this. Kind of clean here for the comment marker, 2 dashes. Interesting. You know, every language has different little things. We've seen the pound sign or slashes, but the 2 dashes are kind of, I don't know, nice. And we can have white space and these different types of things here. Okay. Making the command line available. Okay, so we need to do with ada.command line and get these 2 functions here that are part of the function arguments. So argument count, or argc, as many of you folks see in like the C and C++ language, and then they're called argument. Okay, and then we're going to loop through them. It's going to look something like this. For next in first value dot dot last value loop. Okay, let's go ahead and do it here. Let's bring in that package, Ada with ada.command underscore line. And we've got our main procedure here. Now, interestingly, you know, this wasn't like the main function. It just executed this block. So I wonder if there is a default entry point here. So let's see how we kind of structure this program here. Okay, but anyways, procedure. Okay, this is still our hello world here. So we're going to say for next in one. Oh, interesting. I wonder if this is a one-based language or if it's just one because the first argument is always the binary name. We'll find out soon. Dot argument count loop. And then what are we going to do within this loop? Ada.text IO put line Ada.command line argument and then next. Okay, so this is sort of the range-based for loop in other languages. And then we're going to end the loop. Okay, interesting that there's specific syntax for that. I mean, we're saying for, and then specifically we're ending this loop here. Okay, so let's go ahead and see what happens here. I wonder, let's try to mess this up just a little bit. So if I say end hello world 2 instead of end hello world, does it throw me an error here? Yeah, misspelling of my hello world here. Okay, so it is capturing those types of errors. And this runs here. It just gives us our hello world. We didn't provide any arguments here. So Mike is trying Ada. Again, here's my binary, my hello world. Here's my arguments. And then here was the build system here, just so we don't, right? I'm just making the one file here. Mike is trying Ada, and hello Ada. Okay, so that works. And I think this is just a regular 0 index thing here. Let's go ahead and do 0 there. There we go. Oh, failed. Range check failed. Okay, maybe it is one based. Interesting. Okay, so we shall see here. But okay, this ran, and then we did provide our arguments here. I'll print these words. Okay. And then otherwise, yeah, with this ALR tool, you can set your args here in quotes, just like other languages. Okay. Okay, so getting a feel for the language a little bit. Let's see if we can find some of the more like advanced features though. Yeah, let's get into the overview. The big 5 structural elements here. Okay, packages to group things together, and units of compilation. Again, sort of borrowed from Pascal. Subprograms, reusable sequences of instructions. Fair enough. Yeah, functions and procedures. And then generics for arbitrary types. Okay, so they're data types and so on. Tasks for parallel things and protected objects. Okay. Let's see if we can find some of these here. Ada descends from Pascal, yet uses many concepts in C and C++. Yeah, I don't mind that. I like both of these families of languages. But it's a little bit more formal. I mean, clearly we saw that, right, when I just misspelled my hello world and it tells me. So it's very clear what the scope is of these different things here. Types and Ada, the elephant in the room. Ada emphasized types with the consistent use, but their consistent use despite the complexity means I can ignore them for now. Okay, interesting. Okay, so anyways, let's look at a few of these things. You keep getting a feel of the language. Okay, assignment, again, from Pascal. I like this. I wish every language would use this. Colon equals. I think it's better. I think then you don't mess up the equals equality check with it, but that, you know, that's where we are. Now, already interestingly, in this function here with, I mean, I've got effectively a contract here. Yeah, let's make this just a little bit smaller just so I can fit it. Then I'll, actually, let's see if I zoom in enough here. There we go. Then I'll get the point across. This is effectively a contract. This is coming in. This value is coming in. So effectively, these values shouldn't change when they're coming in, right? They should effectively be like const in some language. But then I have an out parameter here. I like that. I kind of wish all languages, again, had this sort of contract here versus is it mutating, is it not, is it a copy or whatever. Bring data in and then tell me clearly what's coming out. One or multiple parameters is fine, or a structure of things. So already I like this. And then it's interesting to see for a function, yeah, you specify your return type up here. Yeah, I wonder, a lot of languages have the trailing return type and have sort of gone towards that style. Even C++ has trailing return types as an option. I don't write my code like that out of habit, at least in C++. But again, this is sort of Pascal style here. Kind of more readable when you have that, because having the trailing return type means at least for the languages where you type function or procedure out, everything lines up in a block, which is nice. It just looks a little bit more pretty. So I sort of like that. Short functions maybe written as expressions. Hey, that's kind of cool to have a short function syntax. A lot of programming languages, D has a short function syntax. Let's see, multiple subprograms can exist with the same name. Okay, so we've got overloading here for functions. Let's see this idea of packages in Ada. Let's at least get through the big 5 ideas in the next few minutes here. So packages are how we compose the Ada programs. Okay, we have namespaces with the exhibit of logical and physical interfaces. Yeah, a lot of folks don't think about the physical structure of their project. Some programming languages bring this to mind, which is kind of important. You know, even just looking at something like this source directory here, if I run tree, thinking about this actual physical structure and how things are organized and how that often matches like the package system, I think that's actually, I mean, you don't want a project that just has source files all over the place. I know most of us don't intend on doing it, but projects grow large, they grow out of control. You know, different people have different ideas of what is organized. So, you know, yeah, most languages don't have a concept of a physical interface. It's just the things the compiler needs to know, but I think it's kind of nice. And good programmers in languages where you don't have that will talk about it. And it's just another thing to think about. So I don't mind having a constraint for those projects. It's interesting. Ada package is roughly analogous to a header file, and the package body is a source file. So interesting. I wonder if there's a header here. Okay. So anyways, let's kind of keep going here. So basically the directory structure, it looks like, is what helps give the like packages, which is something we do in D. And then you sort of know the order here. Packages can also contain initialization code. Yes, I like that. I want basically again, something in the D programming language, a constructor for at the module or package level or whatever, so I can run at startup. The main, issues here, because C++ has this issue. I think C++ is sort of fixing this with modules. But yeah, a lot of languages have thought about this. Okay, with the pure aspect, to ensure that package has no state and subprograms cannot have side effects. Yes, another feature from D, maybe D borrowed from Ada or vice versa, I don't know. But I like this here. I like these sort of contracts here. Core 10 of Ada. Program text must be clear without having to read ahead, referred to as the linear elaboration of declarations. Clear, how to pronounce this word, demarcation exists between declarations of things to exist and executable statements with those. Okay. Okay, so let's just take a look at some of this code here. Package P is, okay. So not declaring foo here is like making the function static. Okay, I see, interesting. Okay. Or putting it in an anonymous namespace. Okay, so you gotta kind of know a little bit about some other languages. I've been programming for a little while, and we've looked at many of these series. So, I mean, this is a little bit of cognitive overhead, but interesting. Package body. Okay, so it's almost like a HTML file, right? It's got some structure here. And then you've got your declarations here. Okay, here's the actual body of the procedure foo here. And it looks like we can have nested functions, okay, or nested procedures, right? There is a difference between procedure and function in Pascal family of language. Okay, declare a package here inside the function, so you can. Okay, package what is, okay, interesting here. Nesting of declarations is verbose, but it makes it straightforward to refactor. Yeah, I don't mind nesting packages or functions within each other, because for refactoring purposes, that's useful, right? You don't want to introduce helper functions that become a dependency somewhere else, which inevitably they will, right? If you write the code, someone will use it. So I don't mind these types of things here. Let's see here. Let's see here. We got a function here. Overall makes the declaration feel like a Haskell where clause. Interesting. Inability to use statements and declarations caused me to somewhat rewrite my declarations in a sequential order of constant processing. Interesting. Okay, we'll have to look a little closer at Haskell. I haven't looked at Haskell in quite a few years, although I know a lot of folks love it, but just something that we'll have to take a look at here. Return float 2. Interesting. What is float 2? Double precision, is that what we're getting here versus single precision? Interesting. Float 2 Ada. What are the types of floats in Ada? Here we go, from Radford University. Float 2. Okay, we're gonna have to just find that out later. Interesting here. Okay, we're getting into some wild code here. Function evaluate, context in, and in and out. Okay, other things I recognize from D, which I like. I like when I see, the crossover in other languages. I know we're kind of, looking at Ada, but when you see these features brought in other languages, sometimes it's very useful in the programming language that you predominantly use, whether that's, for me, it's C++ and D these days. But it kind of helps you understand some of those features when you see where they're implemented in other languages. That's why I think it's important to do these sort of investigations, because you'll either see it used in a different context. You can see where the feature may be evolved, and maybe even it's just an example from a tutorial that helps sort of explain that feature. So it's just kind of neat to see it in different contexts as we dive in here. Let's see, Ada does not provide separate syntactical units for classes, structs, and namespace. Instead, packages contain types, constants, and related subprograms. Okay, that's probably good, because as it's saying, it gets rid of a lot of different types of syntax here. So I wonder if what this is saying is, is this basically a class here? Right, there's no syntactical unit for it, but it's got like data members here, and maybe a behavior here. This looks like a shortened function here. Interesting. Sanitized line. It's got all sorts of interesting stuff here. Okay, we've got like some dependency here. Maybe this is some sort of function returning here. Interesting. Oh, maybe this is the... we gotta think about this or keep moving on. All right, here's the begin block for the function. Here's like the parameters for in and out, the return value, and then the declarations, I'm assuming here. Okay, so we'll have to think about that. Okay, what would be member functions in C++ are the control types of their first parameter. Okay. With in, which are immutable. Okay, yeah, that's in a lot of languages. In is usually immutable, and so on. Okay. In and out here. Axis align, bounding box. Okay. AABB, that's assuming that stands for. And we're trying to figure out that. Okay, interesting. Okay, so, I'm getting a little bit of a feel for this language. I need to see a few examples, a few more examples. Let's see more of the debunking stuff here. Getting started. Let's debunk some myths as we wrap this up. We've got a few minutes here still. Ada is not a dead language. Okay, let's be clear about that. And I know some of you folks who are watching this, clearly we're enthusiastic about Ada, and I am too. I do want to look at least one concurrency thing just to see how that's done. Maybe we'll try to run an example. We haven't run a ton here. Ada can be used for free. Okay, that's what we ended up settling on as far as the compiler. Ada code does not have to be GPL. Interesting. So there's different licenses. Something I don't see as many of these compilers talking about, which is, useful. No company owns Ada, right? It's an ISO standard. Okay. And Ada runs on more than one embedded system. Great. Okay. Tips and tricks, advanced techniques, RAII. I think this is a good one. Good example, meaning showing the C++ alongside Ada, just to give us an idea here. Now, of course, there are more comments here. And I don't really, let's see, they've got records. Okay, interesting here. To look at these side by side, timing out, waiting for all tasks to complete. Yeah, let's see like a little, we might just have to search here, or maybe on the wiki page we can find some more examples. Yeah, let's just go to the wiki page for some concurrency here. Now, whoa, this is like a huge example here. The following example illustrates some concepts of concurrent programming. Okay, let's try to work through this to finish things off here. Two, actually. I do want to look at generics too. Give this a fair treatment. So procedure, traffic. Okay, so here's the type, 10 airplanes. Task type, task representing airplanes with an ID. Okay, simple enough here. Reference type, and then let's see what we got here. Okay, end runway, protected type here. The shared runway, okay, so this is going to be, it's protected a concurrency, shared runway, protected to allow concurrent access. Okay, interesting. All entries are guaranteed mutually exclusive. Entry, entry, entry. Okay, so these are like the states or something. Interesting. Type, runway access is access all. I mean, there's a lot of interesting things we have to learn here. This must be one of the things where once you learn Ada, this must be very clear. And again, you can imagine building a compiler that is able to catch errors. If you know for every airplane, whatever the ID is, for each of these tasks, if they have like read and write access. I mean, I wonder if it's building like a dependency graph of some sort behind the scenes where you can figure out, who's getting read and write access to this shared resource, this runway here. Now can we actually just run this code? Let's see if we just paste it here. Let's see how good Wikipedia is. Some of these entries here. This will be kind of wild here. Here, let's get rid of everything. So paste just to run one fun example here for our hello world. Okay, it is running here. Let's try to like walk through it in the code editor here. We've got 10 airplanes. Here's our context here running. Okay, we can make that a little bit smaller here just so we can see more of the code here. Let's see if we can get to like the concurrency here. Protected body. Okay, so here we've got the different airplanes when they're running with different begin and end blocks here based off of the state. Okay, so this is the implementation of the above types, right? So, okay, so again, we have to cover some of the syntax. Ada is something I'm going to need a book to learn here. This might be one of the more trickier languages that we've looked at in a 1 hour time span here. But it's sort of clear in an interesting way and how it's verbose. When clear is, okay, so when we're in their state, run this. Fair enough. Entry, this state. When we're, in this state, do this here. And these look like the 3 states. So maybe we have some like enum here. Where was that? Where we had our runway type, right? The cleared, and waiting for clear, and then the state here. Okay, interesting. So that was neat to actually see this running here. I bet, this is the type of code that takes forever to get written once for a rookie like me. But once it works, maybe it just works forever. I mean, this is kind of interesting here. It's so... I mean, it's kind of clear here, right? With a task-based parallelism. It's actually not too bad. Thinking about this, but for me to write something like this, I'm clearly not at that level right now, but that's interesting. Okay. So a nice sample from the Wikipedia to maybe run through. I would want to break this down a little bit smaller examples here. Let's see the generics. Let's see here. Let's just search maybe. If I search Ada generics, bring in another browser tab here. I just want to see like a really example. Type T. Okay, so you just kind of like assign it some generic type here. That's pretty clean. I've always liked how D's done their generics. To basically just have parentheses and then the type parameters here. This is also fine. Again, very Pascal style here. So this is fine as well. So that's pretty clean here. Okay. Formal object declaration here. Now I wonder if you can constrain the types or put concepts on it, which is the one thing. Again, as we just have a few minutes, we can't leave without Because thinking about concepts in some programming languages like C++, that's a way to constrain like the types and so on. But if Ada is a design by contract language, we got to look up a few of these things. So talked about aspects here. Let's see exactly what that means here. So aspects are certain properties of an entity that may be specified, depending on the kind of entity, by an aspect specification. Okay, so this is like a concept or something in C++. Interesting. Which is basically like a template constraint in D, I think. If an aspect is not specified, it's up left to the compiler to prescribe that. Okay. Interesting. It looks like it's got a bunch of different things here. The bit order. Looks like we can write different predicates, a pre and a post function. Okay, cool. So this is part of the contract stuff. Now let's do Ada. This is gonna be America Disability Act stuff. Contract pre and post condition. Yeah, let's look at a gem here. This might have been the way to start here. Ada gems. Let's actually look at that. Maybe we'll extend this tutorial just a little bit here. I want to find a pre and a post condition here. Let's see. So how do we write this? Just with a pragma. Okay, interesting. Precondition, argument must be greater than or equal to 0. Post condition, and then. Okay, so these can get quite detailed here. But I'm a big fan of design by contract. Again, one, it organizes your code. You don't just litter it with asserts everywhere. You can just put the asserts in the pre and the post condition to check them. Although you still want to assert to see if at runtime your program gets into a legal state, right, in the bound within the actual object, versus maybe just checking before and after, because it's possible it gets in a legal state in the middle somewhere, but happens to like you get an overflow or something that puts you back in a legal condition. So anyways, I do like this here. Simple as that. Pre and post condition. Okay, great. Let's see what the other gems are here. Okay, this is nice here. So this might be another great resource for you folks to check out here. For us to actually just go through all the gems. Now these don't all look like, beginner level. They look like some different levels here. But I think we're going to go ahead and wrap this up. I've got a feel for Ada here a little bit. Yeah, it looks like, here's another sort of nice introduction. Again, we should have found the Ada core maybe from here, but we can kind of look through this. We've got arrays and records, and yeah, these are nice samples to go through. So glad we found this. If I was going to pick up Ada again to look at it, this is where I'm going to start from next time. Now that we got things set up, looks like it has a pretty mature ecosystem and so on. And let's see if we can find the answer to that. We're in the fixed point types. Oh, we had floats. Oh, interesting. They give us fixed point. Usually fixed point are, you have to implement your own fixed point version of a number with a decimal, right? For like multiplayer games or something, which is kind of neat. Interfacing with C. This looks like it has everything. Okay, so there is a nice ecosystem for Ada for us learning. I'll go ahead and leave this here. The Ada core website seems to be very nice. The Ada Learn one also has some nice resources here. There's books here available. Ada's been around for a long time. I've seen these books at my library. There's Ada 2022, so there's modern stuff. The one thing we didn't look up is if there's a Ada language conference. It looks like there is. Let's see here. Let's go ahead and just Ada Europe here. Okay, looks like there is. I just want to make sure this is on reliable software technology. So yeah, there's an active community for this. I see it pop up in various research venues as well. So it's kind of cool to see, a language that's been around for 43 years continue to evolve. That's a real feat when you think about it when it comes to programming languages. And there must be some merit, some success in various domains where folks are using this, right? Safety critical stuff. Obviously, this is a language to look at if you're building a new programming language and thinking about things like design by contract and so on. So anyways, folks, with that said, hopefully you enjoyed this first impression. I know we didn't write as much code here, but we got to look at some, run some examples, and find some good resources to otherwise look at Ada. So I'm quite happy to finally have taken a little bit of a look at this language here for the first hour. Looks like a language that will take a little bit to master, but it's the type of language that if you probably already know programming and you want to build a secure system, this might have all the tools that you want. And overall, the concurrency didn't look that bad. It looked like it had a relatively clean sort of task-based system, which is probably what you want. I mean, sometimes doing like threads and getting it right? Threads are very easy to start and use, but getting them synchronized and working can be a little bit tricky. So maybe there's a cleaner task-based system here. And it would be interesting to see in the compiler how it can detect some of these common concurrency pitfalls like deadlock, for instance, or maybe it even has tools for race detection and so on, for data race detection. So anyways, folks, with that said, hope you enjoyed this. Comment below. Let me know what other infrastructure are you using, the package manager, or some other ecosystem, because I'd be really curious if you folks are using this with like GCC, the compiler that we downloaded, or whatever here. There's a whole huge world here. You folks probably know a little bit more about it than I do, but hopefully you enjoyed this preview otherwise and learned about one of the older programming languages that's still in use today and one of the leaders, as far as I can tell, with things like design by contract. Anyways, folks, let's go ahead and end it there. Thanks for your time and attention as always, and I'll look forward to seeing you in the next lesson.